In this video, I'm going to show you that when you integrate this, it will then give you this thing here. But in order for me to show you this, I need you to know that when you integrate secant to the power of 3, it will give you this thing here. We've done this before, so I'm expecting you to know this. So let's try and integrate this. So to integrate this, we need to create a triangle, a right angle triangle, in such a way that this thing will be true. Well, for example, if you make the opposite to be x and the adjacent to be a, then the hypotenuse we have no choice but to be x squared plus a squared square root, and then we want to obtain this thing here. So if you look at this thing here, if you look at this, hang on. So this is secant. So secant the angle equals root x squared plus a squared over the adjacent. So that would be a. So so if you times both sides by a, that would then give you this: a secant theta equals x squared plus a squared. So later on we can put this into here later on, okay? And we need to obtain the dx. So looking at this, this is tan. So tan the angle equals x over a. So times both sides by a. So that will then give us this thing here. That will then give us this thing here. And then differentiate both sides. So this is just a constant. So if you differentiate this, it will be a secant squared theta d theta. And then when you differentiate this, it's 1d. Well, it's going to be dx. So now we've got our dx. So we can now put this. So we are basically using trigonometric substitution in order to integrate this, and then we can put this into here. So so this whole thing here will then become this. So so this is that's this block here, and then this block here is this block here. So basically this whole thing here becomes this. So now tidy this up. So a times a, that's a squared. We are integrating it with respect to theta. A is just a constant, so we can drag it outside of the integral. So now it's just a matter of integrating secant to the power of 3. We've done this before, so I'm expecting you to know this. When you integrate this, it will then give you this thing here, and I've already made a video on this, so track it down. Well, anyway, when you integrate this, it will then give you this whole thing here. So now let's get this times this. That will then give you this. So that will then take us to here. But we don't want the answer in terms of theta. So we need to translate it back to its original x and a. We don't want the answer in terms of theta. We don't want the answer in terms of the angle. We want the answer in terms of x and a. So let's translate this back. So secant theta is this thing here. Secant theta is hypotenuse divided by the adjacent. It's the hypotenuse divided by the adjacent. So secant theta is this block here. And then what is tan theta? Well, tan theta is really x divided by a. X divided by a. Well, tan theta is really x divided by a. So that block there, tan theta, is x over a. And then what is secant theta? Well, we did it earlier. It's this thing here. So that's this thing here. And then tan is x over a. Tan is x over a. So translating all the thetas back into x and a would then give us this thing here. So now it's just a matter of tidying this thing up. So when you tidy this thing up, it will then, well, a squared and a squared here. So that will then, and then that would just leave you with the x. The x is really x over 2. X over 2. And then this times this whole block here will then give you this. And then you've got your constant. So overall the answer is this. Okay?